Hello everyone. What are the moons of Mars? Let's find out. When we gaze at the night sky, Earth's moon stands out as a bright, ever-present celestial companion. But Mars, too, has moons of its own, albeit ones that present a stark contrast to our large, familiar satellite. The Martian moons, Phobos and Deimos, are small, irregularly shaped, and hold a mysterious origin story that scientists are still seeking to unravel. Let's dive into the unique world of these Martian moons and explore what makes them so extraordinary. At a glance, Phobos and Deimos offer a striking visual contrast to our own moon. They're far smaller. Phobos, the larger of the two, has a diameter of only about 22 kilometers, and Deimos is even smaller at roughly 12 kilometers across. Unlike the relatively smooth, spherical shape of Earth's moon, Phobos and Deimos are lumpy and irregular, looking more like captured asteroids than traditional moons. Their cratered surfaces tell a story of a violent past. Both Phobos and Deimos bear the scars of countless impacts throughout their history. On Phobos, a particularly prominent crater, Stickney, dominates one side of the moon. This impact was so powerful that scientists believe it came close to shattering the tiny moon entirely. Grooves and chains of smaller craters radiate outwards from Stickney, hinting at the near-catastrophic event the Martian moon endured. While their appearance is captivatingly unusual, it's the orbits of Phobos and Deimos that set them apart from most moons within our solar system. Phobos has an incredibly close orbit to Mars, circling the planet at a mere 6,000 kilometers above the surface. It completes an orbit in less than 8 hours, meaning an observer on Mars would see Phobos rise and set multiple times within a single Martian day. Deimos, while further out, still maintains an unusually close orbit by moon standards, circling Mars in just over 30 hours. Adding to their intrigue, both Martian moons are tidally locked to their host planet. This means that they always show the same face to Mars, just as our own moon always presents the same side to Earth. The peculiar orbits of the Martian moons, especially Phobos' extremely close proximity to Mars, hold profound implications for their future. Phobos isn't just orbiting Mars, it's slowly spiraling inward. Due to tidal forces, the tiny moon is getting closer and closer to the red planet by a minuscule yet inexorable 2 meters every century. Scientists predict that this inward spiral will ultimately lead to a cataclysmic event. It's estimated that within the next 50 million years or so, Phobos will either shatter under gravitational stress and potentially form a ring around Mars or collide directly with the planet's surface. Deimos, further out, appears safe from this dramatic fate but faces the possibility of being flung away from Mars entirely by the gravitational disruptions if and when its larger sibling meets its end. Perhaps the most intriguing question about the moons of Mars lies in their origin story. Unlike Earth's moon, which is widely believed to have formed from a colossal impact between the young Earth and a Mars-sized object, the origins of Phobos and Deimos remain shrouded in uncertainty. Several captivating theories are under consideration. One leading theory posits that Phobos and Deimos are captured asteroids. Early in the solar system's history, the orbits of asteroids were more chaotic. It's possible that Mars, with its gravitational pull, snagged a couple of these stray space rocks from within the nearby asteroid belt, trapping them into its orbit as moons. The composition of Phobos and Deimos seems to support this theory as it bears similarities to the type of material found in certain carbon-rich asteroids. Another intriguing theory suggests that Phobos and Deimos are remnants from a much larger Martian moon that disintegrated long ago. A massive collision with another celestial object could have shattered this ancient moon, with Phobos and Deimos representing the largest surviving fragments that remained in orbit around Mars. Further variations of this theory suggest that perhaps several past generations of moons formed and were destroyed around Mars, with Phobos and Deimos simply being the latest survivors of this ongoing cycle of destruction and reformation. Some scientists even propose a co-formation scenario, suggesting that Phobos and Deimos formed alongside Mars as it coalesced from the swirling disk of dust and gas surrounding the young Sun. This idea implies that rather than being relative newcomers to the Martian system, these moons have shared the planet's cosmic journey from the very beginning. Unraveling the mystery of where Phobos and Deimos came from carries significance beyond understanding the history of Mars. Studying the composition of these moons could provide clues about the environment and building blocks present in the early solar system. Discerning their true origin offers invaluable insights into the processes of planetary formation and the evolution of our solar system as a whole. Exploring the moons of Mars presents its own set of unique challenges. Their small size and low gravitational pull make it difficult to achieve stable orbits around them from which to conduct detailed studies. Yet, the allure of solving the puzzle of their origins and the potential insights they hold about the Martian system fuels a compelling passion for further exploration. Missions like the Japanese Space Agency's Martian Moons Exploration (MMX) plan to not only study Phobos and Deimos remotely but also aim to return a sample from Phobos' surface back to Earth. Analyzing this sample directly for the first time will be a groundbreaking step in resolving the long-standing debate about where these enigmatic moons came from. The moons of Mars, with their odd, asteroid-like appearance, dynamic orbits, and uncertain past, underscore the diversity found within our solar system. From their cratered surfaces to their potential link to the early days of planetary formation, Phobos and Deimos remind us that even small and seemingly unremarkable celestial bodies can harbor captivating stories. These diminutive moons challenge us to expand our understanding of moons as familiar, spherical companions and serve as a testament to the ongoing evolution of planetary systems. As we persist in exploring these ancient remnants orbiting the red planet, we take one step closer to unlocking the secrets not only of Mars, but of our entire cosmic neighborhood. Thank you for watching. Please follow for more related videos and see you later. Goodbye.